Let's imagine the scenario of farmers picking apples from their orchard, and we're measuring how long it takes them to pick all of the apples. Now, it's fairly obvious that the more farmers there are helping to pick the apples, the less time it will take to pick them. In maths, we call relationships like this inversely proportional, which just means that as one of the variables increases, the other variable decreases proportionally. So in this case, as the number of farmers increases, the time taken decreases, and then the fact that it's proportional means that they increase and decrease at the same rate. For example, if the number of farmers doubles, then the time taken will halve, or if we had 20 times as many farmers, then it would take 20 times less time to pick the apples. Next, we need to look at how we can show these sorts of relationships on graphs, and these will always have this sort of downward sloping curve. If we start in the top left, we can see that this point corresponds to only a few farmers and a really long time taken, but as we move down and to the right, like to this point down here, the number of farmers gets bigger and bigger because we're moving to the right, and the time taken gets smaller and smaller because we're moving down. Another thing that we can do is express the relationship as an algebraic equation. The key thing to understand for this is that saying that the time taken is inversely proportional to the number of farmers is exactly the same thing as saying that time taken is proportional to 1 over the number of farmers. So if we let time taken be t and the number of farmers be f, then we'd have t is proportional to 1 over f. To write this as a proper equation, though, we need to change the proportional sign to an equal sign. And to do that, we have to include a constant of proportionality, which we normally show with the letter k. It's up to you where you put the k, but we normally put it in the top right of the equation, like we have here now. The particular value of k depends on the specific relationship, so it could be anything like 0.48 or whatever. If we pretend that in this case it was 8, though, then, as you can see, we now have an equation that we can use to convert between time taken and the number of farmers. For example, if there were 2 farmers, then f would be 2. So we could put the 2 into our equation and find that time would be equal to 8 divided by 2, so it would take them 4 hours to pick all of the apples, whereas if there were 5 farmers, then we'd do t equals 8 over 5 to find that it would only take 1.6 hours. So because we had more farmers in this second case, it took less time to pick the apples. So to sum up this video, inversely proportional means that as one variable increases, the other variable decreases proportionally, and we can show these relationships on graphs which will always have this downward slope, or in equations, for example, like y equals 2 over x, which will always have one variable equal some number, which we call our constant of proportionality, over the other variable. And one last thing to point out is that it doesn't matter if there are other numbers next to our variables, like there's 3 or this 5, as long as one variable is equal to something over the other variable, then it counts as inversely proportional anyway. That's everything for this video. So hope you found it useful, and cheers for watching you.